I have some introductory material before we jump into the content. Welcome to today's webinar, Use of Scrambled Datasets to Enhance Research Collaboration and Productivity. This webinar series is coordinated by the Aging Initiative, which is an NIA-funded initiative that bridges the expertise and leadership of two powerhouses for research on multiple chronic conditions, the Healthcare Systems Research Network and the Claude D. Older American Independent Centers, or PEPPER Centers. The Aging Initiative is led by Dr. Jerry Gerwitz at the University of Massachusetts and Myers Primary Care Institute, along with co-PIs Elise Adams and Jay Magaziner. My name is Leah Hanson. I'm a senior investigator and the Senior Director of Neuroscience Research at HealthPartners Institute, and I'm a part of the Aging Initiative Dissemination Workgroup, where I co-lead with Heather Whitson at the Duke University School of Medicine. Before we get started, I need to cover just a few technical details. Due to the number of registrants for today's webinar, we have placed your phone lines on mute to reduce audio feedback. So unless you are logged in as a host or panelist, your line is muted. However, we welcome and encourage audience participation using the Q&A or chat features of the webinar software. If you're in our Cisco webinar portal, look at the row of circles across the bottom of the screen. Click on the chat bubble icon until it's highlighted blue. And if you have questions for our speakers, please click on the Q&A tab on the right side of the screen and type in the Q&A box. Heather and I will keep an eye out for your questions under that Q&A icon. And as time permits, we'll read questions for our speaker after the presentation. If you have technical or logistical questions, we ask that you submit those using the chat box that is above the Q&A box. Please make sure you're identified by either your name or your participant ID, so our webinar hosts will be able to troubleshoot any problems you're having with audio or other issues. With the chat function, you can choose whether you'd like your comment to be visible to all participants, or you can choose to send the question only to hosts. We extend a huge thanks to Catherine Anzoni and Krista Lude at Myers Primary Care Institute, who do amazing work behind the scenes to make these webinars possible. They'll be monitoring the chat functions today to help you with any technical troubleshooting issues. And now I'd like to introduce today's speaker. Dr. Alan Goh is the Regional Medical Director of the Clinical Trials Program for Kaiser Permanente, Northern California, as well as Chief of the Cardiovascular and Metabolic Conditions Research Section at the Kaiser Permanente, Northern California Division of Research, and Director of the Solutions Through Technology and Advanced Analytics Research, or STAR Group. He's a Professor of Epidemiology, Biostatistics, and Medicine at UCSF, and Consulting Professor of Medicine, Health Research and Policy at Stanford University. Dr. Goh is an internationally recognized epidemiologist, outcome researcher, and clinical trialist in cardiovascular medicine and kidney disease, with 2 decades of continuous funding and more than 400 publications. He's led multiple large multi-center research efforts, including directing the Cardiovascular Research Network, a research consortium of healthcare delivery systems within the HCSRN that has leveraged expanding electronic medical records and an associated standardized virtual data warehouse. In addition, he has spearheaded efforts within Kaiser Permanente and the CVRN on ways to conduct pragmatic and traditional randomized clinical trials, including a novel pragmatic pilot trial, RBC Heart, involving the systematic testing and treatment of iron deficiency anemia with IV iron in older adults with heart failure. Dr. Goh has been annually recognized by Clarivate as being in the top 1% of researchers in clinical medicine globally since 2015, and recently recognized in 2019 as being in the top 0.01% of all published researchers. We're very pleased to have Dr. Goh with us today. Thank you so much for being here to share your work with us.
Thank you very much, and a real pleasure to talk with everyone today about our experience in the Cardiovascular Research Network and how we can enhance collaboration using a scrambled data set approach. So I'm going to keep going, and if you could let me know if you have any problems with the slides, I'll be happy to try to work on that. So what are we going to cover today and our goals? Well, the one thing is that we face challenges in any kind of multi-center collaborative study of how to get the most out of it, and we're going to work on a potential approach for that. So in terms of the typical ways we collaborate in the Cardiovascular Research Network and more broadly in the HCSRN, that would be something that will hopefully be many of your experiences and can talk about the strengths and limitations of that. We'll then talk about the rationale for the use of scrambled data sets in the approach and how we can leverage that to enhance productivity, as well as how the implementation of the scrambled data set method can be done, and use a successful example and talk about sort of where we'd like to see this go in the future. So first, let's talk about the challenges that exist in the multi-center collaborative studies and use that just to help get to the rationale of why we're proposing this approach and why we use it. So as many of you may experience in various collaborative studies and certainly within the cardiovascular research network is that individual sites that contribute to a multi-site collaboration often spend a lot of time just generating linked data sets within their sites. It then gets sent from there to a primary or lead analytics center. And in that case, that group will take the different data sets together, assemble them, pool them, work with the individual centers to clean and produce ultimately a linked data set and a pooled one, and then get to finally the work of completing the primary specific aims of that funded project. Now, I'm sure it hasn't been any of your experiences, but it has been in ours that we often find ourselves during the award period not having enough time to complete all the work. And on top of that, through the collaboration, we often see that there are new ideas that get spun off of the specific aims and often don't have enough analytic capacity to handle all of those. And in addition, over the years, we've experienced that the ability to have omnidirectional data use agreements between institutions can get more complicated depending on what the project is, the types of data sources, and the different institutions that we might all work with. And that often sets up barriers for us to be able to maximize the productivity of this often very substantial effort that's been made. So when we think about traditional or typical collaborations that we've experienced in the CBRN and the HCSRN, this is often how it goes. So a common framework, and you can see here faded in the background, is a picture of the virtual data warehouse. And the virtual data warehouse structure, as many of you may know, is born out of the HCSRN as a way to standardize and map variables from each of the participating centers' EMRs, and to use that to have more efficient ways to put together pooled data sets and to analyze them by taking advantage of the collaborations we have. In the CBRN since 2008, we've now had more than 20 successfully funded multi-center studies. All of them use either as a primary data source or as one of the main data sources, the virtual data warehouse from the partners, with the largest collaboration to date involving 14 CBRN health systems that combine virtual data warehouse data together into a single pooled data set. So as you might imagine, this really builds on one of the major strengths of the HCSRN and the CBRN, which is you can maximize generalizability by real-world populations, real-world data from multiple places across the country, different practice settings, and that really does allow us to have increased precision and power when we want to answer selected questions, as well as the ability to do subgroup analyses that would not otherwise be able to be done at maybe a single institution. But this does come with some challenges. One of those being that there often is a challenge to compare apples to apples, or really reflecting the fact that there's variability of data across different centers. And also, there can be inconsistent update schedules for an individual site's virtual data warehouse, and also the number of new data types and variables may be variable across the sites. So these all things contribute to what's relevant today, which is to be able to get to the aggregated pooled data set that an analysis can be done on. A lot of the core work is just to get the data set put together. And then frequently, at least in almost all of the CBRN projects, there's a lead analyst or lead analytics center, and the pressure is on them to complete the primary aims. And again, as I alluded to earlier, the fact that we may have to create up to 14 or 15 or 16 reciprocal DUAs can make it challenging if we want to be able to share that aggregated data set in a limited data set way or a more identifiable way. And we are very aware of the changing regulatory requirements that are being put on all of our institutions. And this often creates a barrier to maximize the productivity of this type of collaboration. So that leads us to the rationale of exploring the use of a scrambled data set approach to both enhance our collaborations, but also productivity from this type of funded effort. So what does that entail? So by its very description, a scrambled data set would be fully de-identified and compliant with any individual or central IRB and institution's regulatory requirement. Of course, we want to protect the privacy and confidentiality of the individual members whose data we're using in these types of collaborations. Very importantly, as a solution, or at least a way to complement a lead analytics center, is that this approach means that one institution's analytic group doesn't have to do necessarily all of the proposed analyses. And again, as projects go along, we've all experienced new ideas come along. How do we actually get those done and take advantage of the work that's been done and the data set that's been created? The scrambled data set also allows us to work with essentially any collaborating investigator who has some analytic skills to develop and test programs. And I'm really going to emphasize the fact that we have a collaborative approach to this. So it's not about the public use type data set, and I'll share with you that. So the idea also is that the tested analytic programs that are done by our collaborating researcher can be run on the actual data set very efficiently by the lead site analyst. And that's a real advantage of this approach. So it's important to distinguish between the scrambled data set versus a public use data set. And this is very important when we think about EMR-based data because there's often a lot of sensitivity around that. So in the public use data set, and many of you may have used these, the NIH and other institutions have this, that they're fully de-identified and for the most part freely available. It usually doesn't cost much in terms of getting it, if anything, and you can download it to your computer if it's approved. One of the issues about that is almost always they're completed studies or waves of studies and can often be released only years after a study is over or after the primary publications have been done. And so that leads to data that tends to be aged and leads to other challenges. And one of them, and I've experienced this both as someone who's proposed and built public use data sets as well as used them, is that you're limited to whatever those study investigators are willing to describe in terms of data documentation. And that can be a limitation. Furthermore, depending on the activeness of that study, is that it's often you're not able to get additional variables or even get clarifying details if you have questions, or when you're analyzing it, that patterns or values end up showing up that you're not really expecting. So how is that different from a scrambled data set? So first of all, it also remains fully de-identified, and we'll show you what that involves. But we have to think about the fact that someone has to generate that. So it does take some resources at the lead analytics center to not just generate the scrambled data set, but also to run the final statistical code that was developed in collaboration with an external collaborator. But one advantage is that you can create it much faster than using a limited data set way. And because it's fully de-identified, it doesn't require, for the most part, additional DUA changes in any way. The other thing that we really like about this approach is it really does promote collaboration. So the study team will work with investigators and teams to think through an analysis and what's really needed for it, and then allows that external collaborator to develop code, continue to have conversation with the study team to resolve any potential data issues, and also to work through making sure the code works. And then if needed, depending on the study, we can actually add in new variables if it really is a high priority. And so you see a difference in these two approaches where the scrambled data set is a very active approach, but it also takes advantage of the analytic skills of folks who are outside the primary study team or lead analytics center. So how do you implement this? How does it actually work? Well, first of all, I want to give a lot of credit to the group here in Kaiser Permanente of Northern California who wanted to pursue this, and they did this through something called the distance study. So Andy Carter, Margaret Wharton, and Howard Moffitt were trying to find a way to work with a lot of trainees that came along through this collaboration where they just were running out of analytic effort at our center. And so the objective was, how could we develop and implement a way to promote scientific collaboration and data sharing, which distributes the analytic burden, but protects our patient privacy and confidentiality. And so they went into the literature and also into the statistical methods and said, how can we do this using a scrambled data set approach? So a lot of what I'm going to share with you really is derived from their work, and they also, in addition to this paper, have freely available code in SAS that can be used to help make this happen. So what is the approach to doing this, and what we've done now in the CVRN a couple times that we seem to think works well? So first of all, as I've been mentioning, the typical CVRN project is working with multiple institutions and then pooling a data set together at a lead analytics site. Now, from there, we'll entertain manuscript proposals, both within the study team and also with other collaborators who want to answer a question, and then we institute a publication presentation committee or a steering committee that reviews it and says, yes, this is a good idea, and that we want to work on this. And these are separate from the specific aims because those are the primary funded ones, but these are additional ideas that we could take advantage of that data set that's been put together. And in this case, we will go and work with that proposal submitter and determine what are the variables that are needed for that approved analysis so that we can now go move forward to construct a de-identified scrambled data set. And then because of the fact that it's de-identified and scrambled, we're actually able to very easily transfer that to the collaborator. And there's some key aspects of that type of data set that I'll describe next to show you why we can do that. And it doesn't require we do it securely, but it doesn't require a lot of extra protection. Now, the external collaborator was able then to test code, and depending on what type of program they want to use, I've just given some examples here of SAS or Stata or R, then the data set can be constructed accordingly. But either way, they're able to go and apply that code onto the scrambled data set to do their descriptive and multivariable analyses. Now, the interesting part is that the results themselves, other than what I'll show you in terms of marginal, the margins, are just not meaningful data. But the key is that the code will work. And so ultimately, when you refine the code and you can look at basic distributions of variables to make decisions around cutoffs for example, a continuous variable, or you want to understand feasibility around a dichotomous variable, you can do all those. That all works, and you can run a multivariable model that can be fairly complex. It's just the results are not meaningful. So ultimately, we're able to finalize code in collaboration with that proposal submitter, and then that gets sent at the end to the lead analytics site, who hopefully, if everything works well, can run it very efficiently on the actual data set, which of course then allows us to jig that output very quickly and send it on to the collaborator for their presentation, hopefully manuscript and publication. So this is the general approach that we use to do this, and then I'll walk you through next how we actually implement it itself after I go through some basic definitions. So when we're talking about scrambling, it means that the data set variables are still essentially all there, but they are randomly reordered. And so the marginal values of the variables are left intact, which would mean things like, well, I just want to know the proportion of participants that are women. That's all going to remain there. You can do that work. But I'll show you how the conditional values get randomized within records so that there can be no re-identification and that the participants who contribute the data are fully protected. Now, I also want to clarify that this isn't just reordering every variable column within a data set. It's actually moving data within records so that we can be very sure that it is completely de-identified. Now, when you think about that, that means that you have to have certain variables that are highly related to remain connected. Otherwise, when you try to apply the code, you'll get funny, even descriptive data that will make it very difficult to pursue the analysis. And I'll show you an example of what that looks like in terms of important variables staying linked together throughout the scrambling process to allow the code to still work. And at the end of the day, we are able to either transform or mask any remaining PHI elements prior to the scrambled data set being completed and then transferred to our collaborator. So what does that mean for grouping? So here's an example of a data set that was in that published paper, and you'll see the variable name on the left side here, what the label is, and then the grouping. So for certain variables, like a medical record number, you can see here that we would be excluding that, but it will be transformed into an encrypted study ID that's not linked to the MRN, that's on its own. You'll see group 1, the patient's sex, and then we start doing some grouping. So for example, it's important when we think about the analysis that you want to run that we have the birth date and the date of the survey completion, in this case like an index date, staying together, because that'll be important for anchoring time for other variables. Obviously, imagine a glycosylated hemoglobin, both the date and the result need to stay together, because if someone has multiple measures in the data set, we want to make sure they're linked together so you can order them properly in your analysis. Similarly, in a self-reported height and weight, when you want to generate BMI and look at distributions of that, you need to make sure they stay together within the same person and within the same time. And then here's just the last example in which 4 variables are linked together because they're all related to questions on a survey around alcohol use. And so these decisions have to be made up front in order to make sure that in the scrambling that we don't scramble so much that you lose important information that have to stay together, so that at the end of the day, the statistical code that's generated will work on the actual data set. So this grouping activity is a very key part of the planning for doing this. So what does it mean when we talk about reordering variables within records? So here's an example of an original data set, and you can see in the gray the way that there's grouping that's put together. So for example, you have study IDs, you have a birth date and survey date, which I showed you on the prior slide, have to be linked together. In record 5 here, you see a glycosylated hemoglobin date and result, both missing, as well as a survey height and weight. And what does it mean when we then apply the code of scrambling and put it together into reordered records? So at the end of the scrambling process, if you just sort of imagine these grade zones, what does it ultimately look like as an example? So here you can see that within records, the groupings will stay together, but the records themselves have those groups reordered. And so in this case, study ID number 6 at the bottom includes the merger of grouped variables across different records, now in its singular record. But if you were to do this across the entire data set, those group variables will stay together, the marginal values will stay correct, and this allows now code to be run accurately to look at certain variables descriptively and ultimately to create code to do analyses. Now, of course, as you can see here, there are actual dates. Those will ultimately be transformed and removed, and I'll describe next a real example of what we did. So how did we apply this to a CVRN project? So one of them is in the focus of multiple chronic conditions and the burden of MCC and clinical outcomes in a large sample of older adults with heart failure. So how did this work? We were fortunate for the Aging Initiative to support a pilot study to do this work that was built off of a pooled data set from the CVRN Heart Failure Consortium. That involves 5 members of the CVRN who contributed data on heart failure patients that were older and linked together a lot of data from their individual virtual data warehouses and associated data sources. The lead analytics site was here at Kaiser Permanente in Northern California, in which we pulled together those individual institutions' data sets and put together a singular one. And in this pilot study, the PI was based at Myers Primary Care and the University of Massachusetts. And we said, well, how could we actually leverage this? Because the CVRN heart failure project that this is based on was actually ongoing and had a need to continue to apply its analytic sources in that direction. But how could we support this pilot study effectively? And so we decided to pursue a scrambling data set approach. So how does that work? So if you look at the original data set, first of all, the pilot study PI put together a proposed analysis, discussed it with the study team, reviewed what were the data elements that were definitely needed for the analysis. So what is the scrambling process that took place? First of all, just like you want to scramble eggs, you have to put together your ingredients. In this case, we replaced all of the individual medical record numbers at the individual institutions with encrypted study IDs. as I described in terms of the general methods, all of the individual dates had to be grouped together depending on what it was. That grouping stayed, but we wanted to make sure that we transformed those dates. And so there were random numbers of days within 730 days that were added or subtracted appropriately to these different dates. So again, you could not have any re-identification of those. We then combined these ingredients. As I described, distinct groups of variables need to stay together. And so we were able to do that in discussion and collaboration with the pilot study PI and their team. And really the goal is just to ensure that individual identifiable patterns are fully disrupted so that if this were somehow looked at by someone else, even if you could apply code to it, you will not get any meaningful result. And so we ultimately did the scrambling process in which each individual participant record with the assembled variables gets a random number at the end, and then they're sorted accordingly. But as I showed you on the prior slide, there's the reordering of different group variables within that, but nonetheless, the marginal values stay the same for all the variables and allows the team that's doing the work now to test their code appropriately. And what are the remaining steps in how this works? So first, our analyst here at KP Northern California sent the data set to the PI and the analyst at Myers Primary Care. They received a data dictionary as well as had the opportunity to have a phone call to go over any of the questions when they had a chance to look at that. They then developed the analytic program in SAS, although they could have used something else, and then tested and made sure that it was working on the Scrambled data set. Again, a real important aspect of this is they're able to look at the distributions of the actual variables and the values in them in an aggregate way. Those are accurate compared to the actual data set, and then test the individual variables by coding. Then with fairly, in this case, relatively minor interactions, frankly, between the group at Myers Primary Care and our group here in Kaiser Permanente, Northern California, we were able to finalize SAS code. It got sent to us and was actually run very quickly on the study data set. And that's just a matter of reviewing it, adjusting any kind of variable as needed, all in discussion with the group at Myers Primary Care. Running it on the actual data set, and then in this case, the results for that analysis were pretty readily completed and then sent off to the group in Myers Primary Care. And then the data were written up, and then additional analyses, of course, are done in response to the reviewers and editors. And sometimes that can be done just by, again, the group, in this case at Myers Primary Care, simply looking at the Scrambled data set and then putting additional code together. Sometimes when it's more complicated, the lead analytics site may need to just do it on their own. So that's just another sort of nuance that's important. But nonetheless, the vast majority, 95, 98% of the work is really being done by the collaborative group. So we're very pleased that now 2 papers have been published through this type of collaboration. Congratulations to Myra Tizmanetsky and group out in Worcester on this paper, leading it on multimorbidity burden and outcomes. In this cohort, published in JAGS in September of 2018, and we have another paper coming out shortly. And more importantly, it allowed us to speed up the work together, the productivity, and ultimately were recently awarded an R01 to continue to expand this work around multimorbidity and its potential influence on treatment for heart failure and the outcomes in older patients with heart failure. So I think this is a success story in which we took this methodology, enhanced our productivity and collaboration, and then learned some things from this process that we think can continue to make it better. So I think overall it's been a very positive experience on our side as a lead analytics center, as well as in the group that was leading the analysis. Number one, it certainly extended the capability of the study team. So even though we had an analyst here, very experienced, very senior, they were very caught up in getting the primary aims of the parent study completed, and this would have been a delay if we had taken this on. So that means there's definitely going to be more rapid completion of the analyses by a group that's working in collaboration, but really doing the work to develop the coding. So again, unlike a public use data set, this took active collaborative planning. And in this case, we used a pilot study opportunity to do that, but really throughout the process, We did systematic contact, reviewed the code, and made sure it was being pilot tested appropriately, answered any questions, built out a detailed data dictionary that we got feedback on and able to refine further, and made sure that we had any clarifying questions answered, and made sure that the team in Myers Primary Care was able to actually complete the final SAS program development. And then again, that made it much easier for it to be run effectively on the actual study data set. I think another very positive outcome was that a junior investigator actually got direct analytic experience on using a unique data set while also working in collaboration with different analysts and different investigators, which we believe was a very positive experience for her and the overall team, and strengthened and made the overall work that we're doing richer. So what are the lessons learned and where are we heading from here in this experience? So we learned in this that before we just jump into scrambling a data set, that getting input from the investigators who are going to lead the work as well as the original study team, that we talk through what are the data elements to group. That's a really key, because you don't want to spend a lot of time basically creating multiple versions of a scrambled data set. So thinking through which variables need to be linked together so that you can have meaningful descriptive data and then put that together in a grouping code and then develop the final scrambled data set. It's really important you do that up front. The other part we learned along the way was thinking in advance about the very specific multivariable models that will be used. So for a lot of our work, they're survival-based analyses. Sometimes they are using only baseline exposures. Sometimes they're time-updated ones. And thinking about things like that in a time-to-event, for example, Cox model, and how the date grouping is set up is important, again, so you can create the scrambled data set once. Otherwise, you start eating into the resources that are limited by the lead analytics center. So that's a part of the planning that I think going forward we would do more explicitly. Also, when you're developing the when you're developing the actual SAS programming, it's very important for the group that's doing it to provide detailed documentation in the program itself, or to create a document associated with it, so that when it comes back to the lead analytics center, if it's for some reason not working, then you can pretty quickly figure out where the problem is and solve it. And the more careful documentation there is within the program itself, our analysts at least have found that to be very easy then to go in and realize, okay, we need to fix this, and then get it to run on the actual data set. So where are we going to go from here? We see the future is for this type of collaborative effort. Number one, I think that it worked well. It was a very manual process, but it is something that's getting easier, and we're really thinking how to semi-automate as many of the steps as possible, so that once you decide on grouping, for example, that we can have these macros in SAS that can hopefully put together scrambled data sets very quickly. The other part is that we've learned, and probably all of this experience, is that the more that you systematically plan your analyses up front, the easier it is to translate for an analyst. And so we are working to integrate the concept of a scrambling data set with the grouping decisions and how you choose variables with a standardized analytic planning template, which is very detailed, ultimately gets translated to tables and figures, mock tables and figures, and that we have the whole process planned out so that when we get ready to do the work, it becomes much more efficient and much more quickly done. The other part in thinking about from a broader project collaboration approach is having this pre-baked into a collaboration, and that is to think about how we can maximize the value of this kind of collaborative work in a multi-center study by thinking up front we're going to incorporate the scrambling data set approach. And this also simplifies DUAs. So if we know that there are going to be distributed analyses, let's say, for example, in our CVAR and heart failure consortium, all 5 sites will want to lead, say, in at least one analysis. If we know that as a lead analytics center, we're going to use a scrambled data set approach, we can simplify those DUAs in terms of sharing back all the pooled data in a de-identified, scrambled way. We no longer have to worry about omnidirectionality in those DUAs, because we know they can still do all their analysis, lead it, develop it, take the leadership role in it, and then still have it run technically at the end only in one center. And that doesn't take as much resources. But thinking about what you need, having a sustainable funding strategy so that when you create these pooled data sets, there is funding dedicated to create the Scrambled data set, to be able to have those interactions needed with an external collaborating group, and then ultimately to run the analysis and output it and be ready for the revisions that are needed in the publication strategy as well, are things that we think are important and will extend the value of the multi-institutional collaborations that we do frequently within the CBRN and the broader HCSRN. And so with that, I hope I've given you at least some insights into this approach, how it can be used to enhance productivity. Appreciate your listening intently and happy to address questions at this point. Thank you very much.
Thank you so much for your presentation. As a reminder, if you have questions, you can type them into the Q&A box at the bottom right of the screen. Heather, it looks like we see you, but I'm not sure you have a phone connection.
I see we've received one question asking if Dr. Go would be able to provide any more detail about the technical scrambling process itself and how this process is done.
That's great. Can we hand the slides back to Dr. Go? Could you put up the slide and just go through the scrambling process one more time?
Absolutely. Let me get back to that. Okay. Okay. So again, let me pause here that when you imagine a data set like you see on the screen here, and you have these different variables, and so this is the original data set that would sit in an analytics center, is that normally if you don't do scrambling and you don't have to worry about sharing with outsiders, you can just analyze the data as it is. But again, when we scramble, we make decisions first about which variables need to link together. So in this case, as I described, the birth date and the survey date, we want to have that together because it creates an important information for things like age at the time of the index date, which is the survey date here. So we need to link that together so that an external investigator who's looking at it wants to look at the distribution of age. Otherwise, then we would have a birth date that's unlinked to the survey date. Now we don't have any anchoring point. So we know that those two variables have to link together for any individual record. Similarly, when we decide we're going to group together the hemoglobin date and result or the height and weight. So those are things in which the SAS code that we can be happy to share the way in which we do this using SAS code, in which we make those decisions, and in the code itself, it maintains those connections. So they basically stay together throughout that process. And then in the code, there's a random ordering, a random reordering within records, and that's what allows us to transform this data set into the final Scrambled data set, where you can see here, not only did the birth date, survey date relatively stay the same, but they've been transformed in terms of the actual dates. You can see that in record 6. The relative distance, the distance between those dates stayed the same, but the actual dates were changed. You'll also notice that for record 6, compared to the original record 6, it's now you have the sex being female rather than male. You've seen that the grouped variable, the missing hemoglobin date and result from record 5 is now incorporated into record 6. And then the survey height and weight from record 2 is now incorporated into record 6. And this was done within the SAS code where it randomly reorders. But if you imagine, I just want to look at the survey height and weight and look just at that variable in the entire data set, and you want to look at the distributions, just say height, That all stays the same. That column will stay the same. The numbers don't change. But if you want to get at BMI, you want to make sure that the pair of height and weight within any individual record represents the same individual, even though you can't identify them. And so that reordering is just built into within the SAS code that creates this kind of scrambled data set. And again, happy to share how that works or what the specifics are, but that it's a pretty straightforward way to do it. I hope that answers the question.
Thank you for addressing that. We do have a question that asks, how can this approach be used in using longitudinal data when you are following patients over time?
That's an excellent question. So that's just really an issue of the planning. So if we know that we want to, this was a survival data set that we used in collaboration with Myra and Jerry Gerwitz and their team, in which there were time to event analyses, but when you want to do things like exposures over time, it gets a little more complicated, but it can definitely be done. It just has to be planned ahead of time so that we group longitudinal exposure, for example, to a drug. We're working on refining those methods so that we can maintain the exposure longitudinally, but scramble that within a record. So it can definitely be done. And we already do that with the outcomes, but it's a very good question around exposures that are time updated. It just requires some planning, but it can definitely be done.
Another question we have is if someone wanted to propose to share a scrambled data set with colleagues, do you have an idea of how much they should budget for personnel time for the process, or what's like a ballpark cost, and how to incorporate this into proposals?
That's an excellent question as well. So it depends a little bit on the complexity, just like the last question of the data set that's going to be shared. I'd say that we have found that it's easier to think about the number of hours of our analysts that needs to be spent in the preparation for this. And I'd say that in the initial experience that we had, it's probably longer than would be the case in the next one. So we think about it that way rather than just a pure dollar figure. I would say that it probably took us, I want to say about, probably for the preparation side, it was probably 5 hours of work just for our analysts to do it. And then it was only probably a couple hours of interaction time with them. I won't count the cost of the study team interaction because it was, again, a proactive collaboration. But in terms of the actual study cost, we really put that primarily on our study analyst. And I'd say that it was really more maybe 10, 15 hours of actual work is what I think happened. And that's probably too optimistic at the initial if you've never done it before. But once we got moving, it was probably around that. And that does not count the time needed to pull together and create the original data set. That's really once you have that in place.
Great, thank you. I know that's a difficult question to try and estimate.
Thanks, Alan. This is Heather Whitson. I think I'm connected now. Can you hear me?
Yes, hi, Heather.
Hi, sorry for the technical difficulties. Thanks for helping Leah.
No worries. I don't see
any other questions on my end.
Chris, do you see any questions we don't?
I think we've addressed everything that's come in so far.
Well, maybe this is Alan. Maybe I'll just say is I think that given the overall positive experience of this, I do hope that as people are thinking about different types of collaborations, and I mentioned earlier one of the motivating forces was particularly for trainees who are within groups. We think about some of the training opportunities the Aging Initiative has really brought to light that these might create real good opportunities for those individuals as well as other collaborators in, again, maximizing the value of these kinds of data sets and enriching not just the productivity, but also the value of the analyses that come out because of that active collaboration and this way to protect institutions, their participants, and the study team in terms of these kinds of de-identified scrambled data sets.
Have you run into any issues with publication yet?
Not so far. I'm knocking on my desk on the wood. That so far, no. And again, the only thing that has come up is when we have to do additional analyses that may require new variables. And in one case, I think we had to end up doing it on the actual data set by the lead analytics center because it would have taken more time to revise the scrambled data set. But to me, that was not a big deal, only because we were close to publication. So I think that was an accepted. We were happy to accept that one.
Great, great. Well, I think I'm not seeing new questions, so I think you've done an excellent job of explaining what could be an intimidating topic for some folks. So thank you very, very much.
Yep, my pleasure.
And I agree, this is a really promising approach. And I think that those who are on the call and seeing the screen in front of them, if you do have questions after this, you could send those questions to Chris or to Catherine. You see Chris Delude's email address there. And when you leave, please do fill out the brief survey for us. It helps us a lot, and it helps for planning future webinars as well. And Alan, thank you again for your talk today. This was really interesting.
Yeah, my pleasure. Thank you very much.
All right, take care.